following linear programming problem. Here the constraints are 4x1 plus x2 less than or equal to 60, 8x1 plus x2 less than or equal to 90, 2x1 plus 5x2 less than or equal to 80, and x1, x2 greater than or equal to 0. It is a common data question. It consists two questions. The first question is the objective function z is equal to 2x1 plus 3x2 is minimized to, and the options are 22.25, 46, 60, 40. And here the objective function is constrained to the constraints which are mentioned above. And here the second question is the objective function z is equal to x1 plus x2 is maximized to. Here the options are 0, 21.8, 16, and infinite. Here this is also an objective function which is constrained to the constraint which are mentioned above. Here first consider the all constraints. That is, first one is 4x1 plus x2 less than or equal to 60, and 8x1 plus x2 less than or equal to 90, 2x1 plus 5x2 less than or equal to 80, and x1, x2 greater than or equal to 0. Now consider x2 on y-axis and x1 on x-axis. Now draw the lines for these equations. Here first thing is x1, x2 greater than or equal to 0. So the first corner point comes from this constraint, that is 0, 0. Now consider 4x1 plus x2 less than or equal to 0. At x1 is equal to 0, x2 is 15. Let us say okay, now consider the first constraint, that is 4x1 plus x2 less than or equal to 60. Here at x2 is equal to 0, x1 is equal to 15. Let us say this is a point of 15, and at x1 is equal to 0, x2 is equal to 60. Now join these two lines. So this is the line of constraint 4x1 plus x2 less than or equal to 60. Now consider the second constraint, that is 8x1 plus x2 less than or equal to 90. So here at x1 is equal to 0, x2 is equal to 90. Let us say this is the point for 90. And at x2 is equal to 0, x1 is equal, this is around 11. So just join these 2 points. So let us say this is 11. Now consider the third constraint, which is 2x1 plus 5x2 is less than or equal to 90. At x1 is equal to 0, x2 is equal to 16. Let us say this is the point for 16. And now consider at x2 is equal to 0, x1 is equal to 40. So now join these 2 points, that is, so this is the constraint for this. So here we have a bounded solution between these 3 corner points, and this is 1 and 2 and here 3. So there are 3 corner points we have, and we will have to find out the coordinates at this corner point. So first find out the coordinates for this corner point. Here it is x1 is equal to 0 and x2 is equal to 16. 0, 16, and here it is x1 is equal to 11 point around 25 and x2 is equal to 0. And here this point is a meeting of these 2 lines. So here this is the first line, 2x1 plus 5x2 less than or equal to 80, and this is the line 8x1 plus x2 less than or equal to 90. On solving these 2 equations, we get this corner point x1, x2 is equal 9.7, 12.1. So this is the solution for the given linear programming problem. So here the question is the objective function is minimized to. Here the objective function z is equal to 2x1 plus 3x2. So now substitute all these corner points within the bounded solution and get the values. So we'll have to take the minimum of those values. So here the minimum value can be obtained by using the constraints and by using corner points, the minimum value of z is equal 22.5. So here the right answer is 22.5, and in the option the correct option is A. A is the right answer. Now consider the second question. Here z is equal to x1 plus x2 is maximized to. Here also we'll have to substitute all the values within the bounded solution, that is all these four corner points within the solution. Here we get a value of 21.8, which is minimum. So here the right answer is 21.8, and in the option the correct option is B. B is the right answer. A reversible heat engine executing 630 cycles per minute draws heat from two constant reservoirs at 1200 Kelvin and 800 Kelvin and rejects heat to a constant temperature reservoir maintained at 400 Kelvin. As shown in the figure, the engine develops 100 kilowatts and rejects 3200 kilojoules heat per minute. So here this is the given diagram. So there are two source temperatures, 1200 Kelvin and 800 Kelvin, and the heat rejected to a sink temperature of 400 Kelvin. So here the work developed by the heat engine is equal to 100 kilowatts. So this is the given configuration. So it is a common data question. It consists two questions. The first one is the ratio of heat drawn from two reservoirs Q1 by Q2 is nearly. The options are 1, 1.5, 3, 10.5. And the second question is thermal efficiency of heat engine is 65.2%, 50%, 33.3%, and 66.7%. Here first we will have to find out the ratio Q1 by Q2. That is the heat added to the engine. That is Q1 is heat draws from the reservoir 1200 Kelvin and Q2 is heat draws from the reservoir 800 Kelvin. So first consider the change in entropy, or for a reversible heat engine the cyclic integral of dq by t is equal to 0. That is here q1 by t1 plus q2 by t2 plus q3 by t3 is equal to 0. Here we have only 3 reservoirs, so that's why we have 3 equations, that is q1 by t1, q2 by t2 and q3 by t3. Here q1 is equal to, we have to find out, that is q1 by t1 is 1200 Kelvin and qd is given by q2 also we'll have to find out, that is, and t2 is 800 Kelvin and q3 is heat rejection and is equal to 3200 kilojoule per minute. Let us say 3200 by 60, so that we get here kilowatts, and it is 400 Kelvin, and it is a minus value because heat rejects to the reservoir and heat rejected from the system. This is one equation. Now consider another one, that is cyclic integral of dq is equal to cyclic integral dw, that is q1 plus q2 minus q3 is equal work done by the system or work done by the heat engine. Here q1 is q1 plus q2 is equal to w plus q3 and is equal to 100 kilowatts plus 3200 by 60, which gives in kilowatts in nearby 153.3 kilowatts. So this is, consider this as second equation. Now solve the above two equations. On solving the above two equations 1 and 2, we get here q1 by q2, that is equal to 3. So here the right answer is 3, and in the options correct option is C. For the first question the correct option is C. Now consider the second one, that is thermal efficiency of the heat engine. Here thermal efficiency of the heat engine is equal to the work done by the heat engine and the total heat supplied to the system, that is W by Q1 plus Q2, but Q1 plus Q2 can be written as W plus Q3. because here we have got Q1 plus Q2 is equal to W plus Q3. So from this we get a value of 0.652 and is equal to 65.2%. So here the right answer is 65.2%, and in the options the correct option is A. A is the right answer.